Hello everyone, welcome to a new video. It is the lecture 4 and it is on numerical methods. This is the part A of the lecture where I will be discussing the Newton-Raphson method, and the numerical methods is one of the most important section from the mathematical physics where people usually leave this topic, but on an average 5 to 10 marks generally comes from the mathematical physics, that is from the numerical method section. And Newton-Raphson method is one of the most important topics that you have been learning since your MSc days, right? And this is one of the most important topics that is asked in the CSI NET exam. So what is the use of Newton-Raphson method, right? So generally it is an approximation method, and suppose we want to find the root of a continuous and differentiable function fx, and we do not know the exact root, but we know a root that is near the exact root. Suppose near the exact root the root is xn, right? Then corresponding to the xn, if I find the point where it intersects the curve, right, that is on this point, and if I draw a tangent to this point, it would intersect the x-axis again at this curve, intersect the x-axis at this point. So this is the new iteration or the new root, that is the new approximated root. Again, if I find the corresponding point on the curve, then this would be this point. Again, if I draw a tangent to this point, then I would get closer to the actual root, right? And that would be my third iteration. Similarly, by following a number of iterations, I would get closer to my exact root. And when I would know that I have got closer to the exact root, that means when the successive iteration values are similar, then I have to know that I have attained the exact root. So this is one of the most important approximation method, right, where you can find the exact root if you know a nearby point of that root, right? So this method is very helpful to find the exact root, right, of a continuous differentiable function. So let us discuss the problems, which is the most important thing. I have given you a brief introduction about the Newton-Raphson method, that what is actually done in the Newton-Raphson method, and the main thing that I am looking into is the numericals that generally comes in the exam. So let us move towards them. This is the first numerical that came in CSI June 2016. The question is, in finding the roots of the polynomial fx equal to 3x cubed minus 4x minus 5 using the iterative Newton-Raphson method. The method is mentioned as Newton-Raphson method. The initial guess is taken to be x equal to 2, right? So the initial guess is taken to be x equal to 2. So I have forgotten to tell you that the equation that governs the successive iteration is this. Suppose this is the initial guess, then the successive guess is given by xn plus 1, which is xn minus the function, the polynomial function of that initial guess divided by the first differentiation of the function, where I will be putting the initial guess, right? Suppose I want to find x1, then it would be x0, that is the previous guess, that is function of the x0 divided by f dash of x0. So this is the Newton-Raphson method. So here the initial guess is given, that is I have taken the initial guess as x0 is equal to 2. Then in the next iteration, its nearest value is, that is I have to find the next iteration. It is a very easy math. That is the first initial guess is given, I have to find the next iteration, that is I have to use the iteration technique once. So the initial guess is x0 is equal to 2, right? I have taken as x0, you may take it at x1, then you have to find x2. It's your choice. But I have taken x0 is equal to 2. Function is given in the question. The f dash x would be 9x square minus 4, right? Then the next iteration will be x1. It is x0 minus f of x0 divided by f dash of x0, right? So we put the values, x0 is 2. F of x0 is putting the value of x0 in the polynomial divided by putting the value of x0 in the the function that is differentiated, that is 9 into 2 square minus 4. So if you solve this out, you would get 53 divided by 32, and if you solve this out, it will be 6.656. But there is one warning that you have to be very careful when you are calculating, because you cannot approximate 6.56 as 6.66, 1.66, sorry, because it is already approximation method. The options are very close to each other, right? So you cannot approximate. Always find what is coming. Don't approximate as suppose 1.66 as 1.67. Keep it as 1.66, right? So the option is 1.656. So this is the correct option. So let us quickly move to the next question, and this question I have named as HOTS, that is high order thinking skill question, and this is not a value based question, right? So using the iterative Newton-Raphson method, calculate the cube root of a number. You are given number, find the cube root. Now in these types of question, you are not given the function or the polynomial. You have to find the polynomial from your own, right? You have to find the polynomial on your own, right? So suppose you have to find the cube root of a number n, right? So the cube root of a number is this one. Suppose the number is n, the cube root will be n to the power 1 by 3, and I have named the value as x. Then this is the technique generally. If you cube on both sides, it is x cube is equal to n, and if you take the n this side, it is x cube minus n is equal to 0. Now you get the function. This is the function, and this is the way to handle these types of questions. You have to find the function in this way, right? So this is the function. Now we have found the function. Now you have to find f dash x. It is 3x square, because there is x cube, n is a constant term, so differentiation of a constant term is 0. It is 3x square. Now find, see, in the option it is xn, right? So you have to find generally the xn plus 1 term, because there is no value present in the question. So to find the nth term, n plus 1 term, sorry. So xn plus 1 is xn term, that is the previous iteration, minus f of xn divided by f dash of xn. So xn minus f of xn would be xn cube minus n, right, divided by f dash x, right? F dash xn, it would be 3 into xn square, because f dash x is 3x square. You have to put xn in place of x. So if you solve this out, this is the thing you get. And if you rearrange, if you take 1 by 3x square 3xn square common, and if you take these things out, you would get this as the solution, right? So if I see the option P is the correct option, right? So this is a very unique type of question. That is why I have named this question as HOTS, right? So let us move to the next question. This is one of the most important question, and it is a recent question, right? It came in CSN at June 2021, right, which was held in February 2022. Let me tell you, I did this question wrong in the exam, because I have already approximated the thing. See, the options are so close, 0.23, 0.24, 0.25, 0.26. My option came out to be 0.238, but in the question it was asked to find up to 2 decimal places, so I clicked the option as 0.23, right? So that is the mistake I have done. That is why I'm telling you, don't do these types of mistake, don't approximate. But I have approximated something, and in the exam I created this type of mistakes, right? So the question is the Newton-Raphson method. Let me erase this first. So the question is, the Newton-Raphson method is to be used to determine the reciprocal of a number 4. So to find the reciprocal of the number 4, if we start with the initial guess 0.20, then after the first iteration the reciprocal is. So you're given a number 4, you have to find after the first iteration what would be the reciprocal of that number 4. So what I have done, I have generally solved without using the number. That is, I have found the general solution for this type of problem. Suppose you have to find the reciprocal of a number. Like in my previous question, I have said that the reciprocal of the number is 1 by n. Suppose the number is n, then the reciprocal would be 1 by n. I am taking the value as equal to x. Then again I am reversing it as 1 by x it equal to n. Then I am taking n this side. So it is 1 by x minus n. This would be my fx. I'm generally finding the solution for any number, then I will put the number as 4. Okay, so you have to find the nth term. It is xn plus 1 is equal to xn minus, this would be f of xn, it would be 1 by xn minus n divided by f dash of xn. So first I have to find f dash of x. It is minus 1 by x square. N is constant, so differentiation is 0. So that is f dash of xn would be minus 1 by xn square. And I'm sorry. Right, there was a network lag. So f dash of xn would be minus 1 by xn square. Then if you solve this out, you get the solution as, if you rearrange these things, this you can do on your own. So it is xn plus 1 is equal to 2xn minus n into xn square. Now I can use this general formula, right, to solve my question. Here I have the number as 4, right, and I have to find the next iteration. Suppose the first iteration is, as given in the question, it is 0.20, then the next iteration would be x1, right? So I am using this one to solve. Then x1 would be 2 into x0 minus n into x0 square. It is 2 into 0.20 minus the number is 4 into 0.20 square. If you solve it out, it is 0.24, right? So this is the correct option. So this was the fresh question, right, that came in June 2021. This is the easy question, but the fact is, if you approximate, the things are going to be wrong. I did the question wrong in the exam. That is why I am giving you suggestion that don't approximate the already approximated method, right? So this video I am stopping it here, right? Because in this video I have discussed the techniques to solve Newton-Raphson method, right? To solve the questions using Newton-Raphson method, I have discussed briefly what you should do, and I have discussed 3 of the most important and uncommon problems, right? So you can approach all other problems on Newton-Raphson method, and if you have any doubt, you can post it in the comment section below. Till then, if you like this content, right, and if you like the already posted contents on my channel, you may subscribe my channel and share the videos with your friends. Till then, thank you, goodbye.